All right, today is all about triangles. And we learned yesterday from our adventure at the beach that there are three different types of angle that we can see in a triangle. We can see an acute angle. Remember, think of our acute little old man who is less than 90. We can see a right angle, Mr. Right, who said he was exactly 90. Or we can have an obtuse angle. Remember, think of OB, who was lounged back, saying he was greater than 90. So when we classify an angle by those three different angles, it's kind of like we're giving a triangle a first, a middle, and a last name. The angle is like the first name of the triangle. So we're trying to figure out what is the first name here. Now, when I give a triangle a first name, I'm classifying it by the largest angle. Okay, so if I look at this triangle right here, all of my angles look like they're closed, right? Like they're acute angles. Actually, let's go ahead and add this. We have our acute, which would be less than 90, a right angle, which would be exactly 90. And remember, that always gets that square in the corner. And then our obtuse angle, think about OB just laying back, chilling in his chair. So when I look at all three of these angles, they all look like they're acute angles. So I would say this is an acute triangle. When I look at this one, I see two acute angles and one right angle. But again, I want the largest one. So my right angle is going to be the largest. And then when I look at this one, these two look acute, but this one looks obtuse. So the largest one would be obtuse. So that's how a triangle gets its first name. And then for the middle name, we're going to classify it by the sides. So this is like the middle name. And we talked about our different types of triangles that we can see based off of the sides. We have an equilateral triangle. So think about our men, our three men who were walking on stilts, those equal ladders. We have an isosceles triangle. Our friend Isosceles out surfing the waves, who was holding two equal packets. So this has two equal sides. And then poor Miss Smith walking along the beach, who had all of those different scales that I kept stepping on. And every time I leaned over, it told me my weight was different than before. So a scaling triangle, all three are different. So when I look at this first triangle right here, I see that this side has one tick mark. This side has two. This side has three. They're all different. So that's going to be a scaling triangle. No sides are the same. This middle one, I see that each side has one tick mark in it, meaning all sides are equal. So this is an equilateral triangle. And then this one right here, I see that this side has two tick marks in it, but both of these only have one tick mark in it, meaning that two sides are the same. One side is different. So this is an isosceles triangle. So first name is the angle, middle name is the sides. The last name of any triangle is just triangle. So this is not on your notes, but we're going to do a few practice problems together here really quickly just to make sure we've got this. So let's say I draw, if I can get my expo marker off, I draw a triangle that looks like this. And I'm going to say this one, and this one. Okay, so it looks like that. Let me turn my light off. So when I look at this triangle, it looks like all of my angles are acute. So first name would be acute. I see that these two sides are the same. This one is different. So two equal sides is going to be isosceles. And the last name is always triangle. So the name of this shape, it is a acute isosceles triangle. Let's try one more. Oh, goodness. Let's try this again. My drawing skills are not great. There we go. That's better. All right. So when I look at this triangle right here, I'm going to say that this gets 1, 2, and 3. So remember, the first name, I've got to start with the largest angle I see, which is this one, like right here. This one looks like OB leaning back in his chair. So this would be obtuse. All of my sides are different lengths, so that's scaling. And then the last name is triangle. Okay, so now that we know all of this information, let's take this one step further. So now let's talk about the sums of the angles in our triangle. So thinking back to our story at the beach yesterday, when I went out to go get my tan and all of a sudden it got dark and I looked up in the sky and there were all of those angry bird kites staring at me in the shapes of triangles. And when I counted them, there were 180 kites up there, 180 triangles. Well, there were 180 of them because the sum of all the angles in a triangle is 180 degrees. So it doesn't matter if it's an equilateral triangle, a scalene triangle, an isosceles triangle. All of those are going to add up to be 180 degrees. So here's what I want to look at. I've got kind of a visual here for us, and I hope you've got your markers ready with me. So let's pretend that I drew this triangle right here. And then I got angry, and so I ripped off all of the corners. I don't know. I felt like it. So I detached all of the angles from our triangle. So I'm going to take my green marker and just quickly outline this one in green. So I'm going to take this green piece, and I'm going to move it to the far right side. And then when I ripped off the top one, I colored it blue. And I'm going to take this blue one and I'm going to line it up exactly on the edge of where I put the green one. And then on the third one, when I ripped it off and it was red, hopefully paper doesn't bleed, that'd be weird. And I lined it up right here. There's something that all of those angles do. Now, yes, in my story yesterday, I did use the number 180 when I talked about all of the kites in the sky, but I also used it somewhere else. So think about my story, and when I talked about after the little old man convention, they didn't want me to leave, and I was ready to leave, so I drove straight home at 180 miles per hour. So what happens here is all three of these angles, when I put the tips of the angles together, when I put those vertexes together, those vertices together, it forms a straight line, which is 180 degrees. So that's why there are always 180 degrees inside of a triangle. So that's good information to know because there are going to be some times where I'm trying to find the missing angle in a triangle. So it says in triangle PRQ shown below. So PRQ. What is the measure of, and this is an angle sign, of angle P in degrees? So when I look at this, angle P, I don't know what it is. So I'm going to use an X to represent that it's missing. I know that angle Q is 20 degrees, and R has a box on it, which means that it is 90 degrees. So here's what I know. I know that if I take all three of these angles and I add them together, I should always get 180 degrees. So I could do X plus 90 plus 20, and again, that should always equal 180 degrees. Now, this goes back to when we solved those one-step equations, right? I want to get rid of what is bothering X. And right now, 90 plus 20 is bothering X. So let's simplify this. I know that 90 plus 20 would give me 110. And again, that's all equal to 180. I'm going to build my T-chart, circle what's bothering the X, and then do the opposite. So the opposite of adding 110 would be subtracting 110. What you do to one side, you have to do to the other side. My 110s cancel each other out. So I'm left with X equals 180 minus 110 would be 70 degrees. So it does want us to bubble this in. So this is a whole number 70. So a 0 goes in the 1 spot, 7 goes in the 10 spot, and then always remember to make your bubbles nice, dark, and neat. All right, let's do another one. Our next one says, in triangle JKL, the measure of angle KLJ is 30.5 degrees, and the measure of angle JKL is 55 degrees. What is the measure of angle LJK in degrees? It's a lot of letters there. Now, this time they didn't give us a picture, so we need to draw a picture here. So I know my triangle, the three vertices are going to be J, K, and L. So I'm just going to draw a triangle. I'm going to name one vertex J, another one K, and the last one L. Now it says the measure of angle KLJ. So whenever they give you angles like that, it's always the middle letter, the one that's sandwiched in the middle. That's the angle that we're talking about. So angle KLJ is just the same thing as saying, hey, angle L is 30.5 degrees. The measure of angle JKL, which again, if I look in the middle, it's just angle K, is 55 degrees. And I'm looking for the measure of angle LJK, which is just angle J. That's what I need to know. So again, I know if I take these three angles, so X plus 55 plus 30.5, and I add them all together, I should always get 180 degrees. So again, what's bothering the X right now is this 55 plus 30.5. So when I add those together, I can draw a plus sign. When I add those together, I get 85.5. And again, that should always be equal to 180. I'm going to set up my T-chart. What's bothering the X here is this plus 85.5. So I need to subtract 85.5 from both sides. Now remember, when I subtract with decimals, I have to make sure that I line up those decimals. So my 85.5s are going to cancel each other out. So I can't do 0 minus 5. I can't borrow from 0. So my 8 is going to become a 7. This first 0 becomes a 9. That last 0 becomes a 10. So 10 minus 5 would give me 5. Bring straight down the decimal. 9 minus 5 is 4. And then I can't do 7 minus 8, so I'm going to borrow. My 1 becomes a 0, and the 7 becomes 17. And then 17 minus 8 gives me 9. So I get that angle J is 94.5 degrees. So when I bubble this in, 9 in the 10 spot, 4 in the 1s, 5 in the 10th spot. And again, make sure we get that all bubbled in nice, neat, and dark.